Hey guys, it's Mr. Lowry again. This is a continuation of the last video where I was going through sections 4.3 and 4.4 in the geometry textbook, talking about some of the key concepts here. In the previous video, I talked about congruent triangles and the definition, and I introduced you to the side-side and the side-angle-side congruence postulates. From there, we were talking about the justification or why these postulates actually kind of make sense. And I went through a construction that demonstrated why the side-side-side congruence postulate works. In this video, I want to start off by just talking about the side-angle-side postulate and kind of explaining why it works. All right, sorry, I have somebody at my window here. So what we're going to do is we're going to make a triangle again, okay? And again, there's nothing really special about this triangle. It's just kind of a scalene triangle here that I'm making. And I'll label the points. Again, the points don't really matter. I'll call these A, B, and C. And the goal here is to copy just the right information. Only a side, an angle, and a side. Okay? So if I copy this side and this angle and this side, I want to see what are all the possibilities that I can have for a triangle that I construct with that information. Okay, so what I'm going to do is I'm going to start with just a plain old line, okay, and I'm going to put a point on that line, which I'll call A prime. So it's A apostrophe basically, and that little apostrophe in math we say prime in this context, and what it means is the copy of A, the copy of the previous point. So I'm going to start with that guy. Now what I'll do is I'll use my compass to set the distance exactly to this distance, the distance between A and C. And I'll use that down here. I'll take this without moving the compass or resetting it. I'll place the point on A prime, and I'll make a little arc here. Okay, and there is going to be C prime, right? I'm going to put the copy of C there because I want this distance to be congruent to this distance, which I just did. So I copied side, right? Okay, there's side. Now what I want to do is I want to copy angle A. Okay, I want to take this angle and I want to put it right here. In order to copy an angle with a compass and straight edge, you need to start by measuring this distance, which we did. But when you're copying an angle, you have to make a little bit bigger of an arc because we don't just want a segment. So we're going to make a big arc here. Okay, use that guy. And that's the first measurement. So we kind of measure basically how far away we're measuring. Now we come across and we measure across the angle. Okay, so we're measuring this way. We set our compass to be the exact distance between B and C. Okay, and then we put the compass on point C prime. So we put it here. And we want to make an arc, another arc. And this will give us a reference point. Now this is not the copy of B. This is just another point. But that point will help me make an angle. So think about what I did. I measured a distance from a point, and then I measured a distance across an angle. And so distance to a point, and from that point I measured across an angle. Okay, that will give me another reference point that will allow me to construct a copy of angle A. Right. So what I've just done is I've copied angle A. So now this angle and this angle A prime are the same exact angle. Okay. Now this point's kind of random. I actually don't, it's not a part of the triangle. It's just that reference point. Okay. So I copied the side, check. I copied the angle, check. Now I just have to copy this side over here. Right. So if I take this guy and I take my compass and I set it to this distance, the distance from A to B, okay, and try to be as precise as possible. I come over here and I duplicate that distance, right? So I'm going to make a little arc there, and there's where my point goes. And now this point here, this is part of my triangle. I'll call that B prime, or the copy of B. All right, so now I have this distance from A to B congruent to this distance from A prime to B prime. So I've copied a side and an angle and a side. But if you think about that, how many ways are there for me to finish the triangle? There's only one. Like, I have to connect B and C. Point B prime is fixed. I can't do anything about it. I can't move it this way or this way because then all of a sudden I wouldn't have the right side length. I can't move C either. I can't move it this way or this way because then I wouldn't have the right side length. I can't even move it this way because if I move it this way, I'm not going to have the right angle anymore. So by setting this side and this angle and this side, setting those sides up and making them like fixed, there's actually only one way to finish the triangle. Whoop. Okay. So there's this uniqueness here. If I fix a side, an angle, and a side, I have to complete the triangle. The 3 points are already fixed, and there's only one resulting triangle. If that's the case, then all the triangles that I make using this side length and this angle and this side length will actually be congruent to each other because they're going to be the same basic triangle. Okay. So that's not a proof. Remember that this SAS is actually a postulate, which is an idea that we accept to be true without a proof. It's relatively obvious. It's kind of a common notion, or it's self-evident. And it may not be completely self-evident to you if you weren't familiar with these tools and the constructions. But the ancient Greek geometers who are kind of coming up with this stuff would have been very familiar with these types of constructions. And so when they looked at, the side angle side, it would have been very obvious. Yep, exactly right. If you have side and angle side, there's only one way to complete that triangle. So that's kind of where that postulate comes from. All right, now with that, let's take those two ideas, the side angle side and the side side postulate, and let's do a couple example problems, okay? So this is not on your homework, but it will help you with your homework. I'm going to draw a couple figures for you here, and we'll see if we can tell if they're congruent. So the goal here is to determine if triangles are congruent. Okay, and so I thought up a couple examples that will use some other properties and theorems and postulates that we've talked about before. So I'm going to draw kind of a rough sketch here of a figure. Okay, so something like this. And let's label it here. I'm going to be kind of boring and just use the same old labels here. We'll call it A, B, C, and D. And let's say that we knew that AB was congruent to CD. And let's say that we knew AD was congruent to CB. Okay? Is there enough to determine, if that's what we started with, like if this was the problem that was given to you, we'll call this number 1, and this is what you saw, could you say, yep, that left triangle is congruent with that right triangle? Well, we have a couple shortcuts, right? The minimum information we need is either 3 sides or 2 sides and an included angle. For right now, we're going to talk about other congruence, congruence postulates and theorems in the next week or so. But these are the 2 that we have so far. When you look at this, you're like, okay, I got side. Right now, it looks like I got SS. Okay, but what you might be thinking, or even like screaming at the screen right now, is what about BD? BD is shared by both sides, right? So you look at this guy, and it's shared by both triangles. And so it's congruent to itself, and so you really have side, side, side. So what I'm asking you to do on your homework is something like this, okay? I want you to say that the triangles are congruent, but not only that, I want you to tell me the other information that you're using, the other theorem, property, postulate. So what I would write is something like this. BD, the segment, is congruent to itself. Now the way the triangle is set up here, it would actually be ABD and CDB. So I'm going to say BD is congruent to DB. Okay. This guy is congruent to itself. And the property that allows me to say that any segment is congruent to itself is the reflexive property of congruence. Right? Any segment is congruent to itself, any angle is congruent to itself. So with this, I can now kind of mark this. Sometimes in the book you'll see they'll actually do like a tick marking that shows like it's congruent to itself. Okay. So now I have triangle ABD congruent to triangle CDB by SSS. Okay. So I want you to tell me if the triangles are congruent Okay, I want you to tell me what postulate you're using, right? So they are congruent, it's by SSS, but there's another piece of information here. I also want you to tell me, what are you inferring? What inferences are you using from other facts that you already know? Sorry, I had to take a drink of water because my throat's getting dry. Okay, let me give you another example here, and this will kind of help prep you for next week. Okay, so what I'm going to do is I'm going to draw a shape, and you might be kind of familiar with this shape. It's going to look kind of like a parallelogram, and we'll do the best to make it accurate. Maybe it's not perfect, but we'll see. Okay, and I'm going to make a line that goes here. Okay, and we'll label these coordinates. Let's change it up here. We'll do W, X, Y, Z. Okay, and excuse me. Let's assume that we know that these two sides are parallel to each other, so we'll mark them parallel. And let's also assume that we know these sides are congruent to each other. Okay? Is there enough information to say that these two triangles are congruent? Okay, well again, what we're looking for is, do we have this or this? Okay? So we definitely have a side and a side. So we can say, look, XY is congruent to ZW, right? We have that side congruent. So there's at least one side. Okay, what else do we have? Well, notice that in the top triangle and the bottom triangle, they both use this side, I guess it's not the hypotenuse, but this side right here is used in both triangles, and that side's congruent to itself. So I would say something like YW congruent to WY, right? But how do I know that? It's not marked in the figure. It doesn't give me that. We actually kind of had to make a little bit of an inference there, and that was this is side, and that's the reflexive property again. Reflexive property of congruence. Okay, so we need something else. We need another side, or we need another angle. Okay, so this is where another idea comes in that we've talked about before. Parallel. Okay, what does parallel get you? Well, let's kind of redo this figure a little bit. We'll just do it in a little bit less detail. I think it'll be a little clearer that way. So we have something like this, right? Basically, two parallel lines cut with a transversal. And so we get like our alternate interior angles congruent and our corresponding angles congruent, and we have alternate exterior angles, right? So if you think about this guy, my alternate interior angles are, or one set of them, are this guy and this guy, right? This is congruent to this. So here's a parallel line, right? Here's a parallel line, here's a transversal. Now kind of ignore these for a minute, it's cutting off some stuff. But we know that this angle is congruent to this angle. Okay, those are like my alternate interior, the kind of one wedged in here and the kind of one wedged in here. All right, now a lot of people want to say like, oh, but these are also congruent to each other. And that's actually, that would be true. But in order to conclude that, you need to do a little bit more work. And the reason why is, if you look at this angle right here, like these guys, they all are alternate interior angles. But notice that this right here is an obtuse angle, and this is not an obtuse angle. If this was a parallel line, the angle is actually this whole angle would be congruent to this whole angle here. So notice that the other alternate interior angle set is actually cut off or cut short by these sides. So you can't necessarily use that as a justification to get the other angle. It turns out we actually don't need that here, but that came up in one of the classes. So we basically have side, angle, side, right? Like here's side angle side of one and then side angle side of another. So yeah, we have an angle. We have angle X, Y, W is congruent, this guy X, Y, W is congruent to Z, W, Y. And the reason why is alt int angles theorem, the alternate interior angles theorem, right? So it's not a full proof, but we're going to do proofs like this next week. And so I want you to kind of start thinking about what other properties, postulates, theorems that you're going to use for inference here. Okay, so one of the sides was given to you, was marked. Okay, this angle comes from alternate interior angles theorem, and this other side came from the reflexive property. So I would go ahead and conclude that triangle X, Y, W is congruent to triangle ZWY, and it would be SAS. Okay, so in your homework, what I want to see is yes, they are congruent, and SAS is Y, but I should also see alternate interior angles theorem. I didn't do a very good job of writing that down. So actually, let's be a little bit more clear. Okay, so I'm using alt int angles theorem. I'm using reflexive property of congruence, and then I'm going to conclude that they're congruent by SAS. So this is what I want to see on your homework. Whoops. I want to see all the inferences that you're making along with your final conclusion. Okay. Now it may be that there's not enough information. I may just have not given you enough information on there. And if that's the case, then you write not enough information. So, talking about these guys here on your worksheet. Right? Now this is kind of a long set of directions because I was trying to say all that stuff. Give me all that stuff. So determine if there's enough information to say the triangles are congruent. Okay, if there is, state which triangle postulate you're using. That would be, say, if it's SAS or SSS or not enough information. List any other properties, theorems, or postulates you're using in your reasoning, right? So reflexive property of congruence, alternate interior angles theorem, vertical angles theorem, linear pairs postulate, right? Like all these kind of ideas are going to be important here for you. If there's not enough information to conclude the triangles are congruent, write not enough information. So that's what you do on these, okay? This one's pretty easy. There's no inferences made. It's just they're congruent by side, side, side. Okay, this one you're going to have to make some inferences. You got a side and a side, but no other information is labeled. Well, here's a right angle, and here's a straight line. Okay, so think about that. So that's what you're going to do here. Any other information you're using, you're going to list. On these last two here, you're going to basically say, okay, I want to conclude that they're congruent. I want to use SAS. What other piece do I know, right? So I have these two angles. Okay, that's cool. I actually have this side XW congruent to WX because it's reflexive. So what else do you need to know? What other pieces would you need to know are congruent? And then write that. Okay, same thing here. We got one side, right? Side, basically. Is there another angle in there? Turns out there is, so you're going to have to tell me why. And then what other side do you need to show that those triangles are actually congruent there? Okay, so I gave you a couple examples, not from the homework itself, but these were kind of other examples here of what you're going to be doing. But yeah, that's the back, and you're using SAS and SSS, kind of applying them. I hope that helps you get started. Remember, all this stuff comes from your book, so the pages that are important for you to understand would be page 192, which talks about congruent triangles, the definition of congruent triangles. Page 201, which talks about SSS, the postulate, and 202, which talks about SAS. So those, along with the video helps and the notes kind of that I put in Canvas here, will be really helpful for you. Thanks for watching, and I hope you guys are doing well out there. Hope to see you soon in class.